Kata is something you practice, not something you watch. Read the lesson, write the code yourself, then review what you wrote. This video is the reference you come back to afterwards. A model can produce this code in seconds, and the reason to write it by hand is to keep the judgment that tells you whether the code is any good. This is the lesson that makes the rest of the performance section make sense, and it answers a question most people carry a wrong answer to for years. When does React actually re-render, and what does it do when it does? The short version is that rendering and updating the DOM are two different steps, and almost every confusing React behavior lives in the gap between them. By the end of this, you should be able to predict which components run, which DOM nodes change, and why a list sometimes puts the wrong text in the wrong box. 3 triggers, and it is worth learning them as a closed list because the list is short and the wrong mental models are all longer. A component re-renders when its own state changes, when its parent re-renders, or when a context it reads changes. That is all. Notice what is not on the list. Props changing is not a trigger. It cannot be, because the only way a component receives new props is for its parent to render, and the parent rendering is already the second item. This sounds like a technicality, and it is the difference between understanding the model and guessing at it. Calling a state setter marks that component as needing to render, and React then renders it and everything below it. That second half surprises people. Changing state in one component does not surgically update one node. It reruns that component's function and the functions of all its descendants unless something stops the descent. Rendering a component is calling a function that returns a description, so this is cheaper than it sounds, and it is also why an unnecessary render high in the tree costs more than one at a leaf. When a parent renders, its children render, whether or not anything they receive has changed. This is the trigger behind most of the surprise re-renders people go hunting for. The default is that a subtree re-renders together, and stopping it takes something deliberate, which is what React Memo is for, and why the memoization lesson said memo is the tool that does the comparing. Until you place a memo somewhere, the whole subtree runs every time. Here is the part that matters most. Rendering does not touch the DOM. What it produces is a tree of plain objects describing what the UI should be. React then compares that tree with the previous one and works out the smallest set of real DOM operations to make the page match. That comparison is reconciliation. The reason this matters is that a component re-rendering is not the same as anything changing on screen. A component can render 10 times and produce an identical description 10 times, and the DOM is touched 0 times. So too many renders is a claim about your JavaScript, not about the page, and that is why measuring beats guessing. The comparison has one rule that explains a whole class of bugs. When React compares an element with the one that was in the same position before, it looks at the type first. Same type C, it keeps the existing DOM node and the component state and just updates whatever props differ. Different type, it throws away the entire subtree, unmounts everything in it, and builds the new one from scratch. Watch the demo swap one element for another and see the state disappear. Nothing is preserved across a type change because as far as React is concerned, that is not the same thing in a new form. It is a different thing. Position works for comparing a single element against its predecessor, but it falls apart for list because the item at index 2 this time may not be the item that was at index 2 last time. The key is how you tell React which element corresponds to which. Give it a stable identity from your data, an ID, and React can match them up correctly no matter how the list is reordered. The key is not a label and it is not for you. It is React's only way to answer the question, is this the same item I had before? Using the array index as a key means telling React that identity is position, which is exactly the thing that changes when a list changes. Insert an item at the front and every item after it gets a new key. So React believes every one of them became a different item when in fact they all just moved. The result is not usually a crash. It is state attached to the wrong row, a checkbox that follows the position instead of the item, or text in an input that jumps to a different entry. That is why the bug is so hard to spot. The list looks right and only the state is wrong. Index is safe in exactly one case, which is a list that never reorders, never inserts except at the end, and never removes. Since a changed key makes React discard the old component and mount a new one, you can use that on purpose. Put the user's ID as the key on a profile form, and switching users gives you a genuinely fresh form rather than one holding the previous user's half-type values. This is the cleanest way to reset a component state that exists, and it is worth preferring to an effect that watches a prop and clears the state, which is the version people usually write and which has a window where the old state is still on screen. The counter here uses a ref to count renders, which is the technique from the use ref lesson, and it is the honest way to find out what is happening rather than reasoning about it. Two things to keep in mind while reading the numbers. In development, strict mode renders twice deliberately, so expect doubles. And render counter tells you a component ran, not that the DOM changed, which is the distinction this whole lesson turns on. For real work, the profiler in the React developer tools gives you the same information with timings attached. 3 triggers own state, parent render, context change. Props are not one, because props only change when the parent renders. Rendering builds a description. Reconciliation compares it to the last one and touches the DOM as little as it can. Same type keeps the node and its state, different type throws the subtree away. Keys give list items identity, index as a key gives them position instead, and a deliberate key change is the best state reset there is. The playground is one file with several demos, so read it as a set of experiments rather than a program. There is a parent with a counter that re-renders children which receive nothing at all, which is the second trigger in isolation. There is a type swap that destroys state. There is a list you can reorder, once keyed by index and once by ID, and it is worth actually doing the reorder and watching where the input text ends up, because reading about that bug and seeing it are different experiences. And there are render counters throughout. Change something and predict the numbers before you look at them. The places where your prediction is wrong are the parts of the model worth revisiting. The model to keep is 2 steps, not one. React runs your component functions to build a description of the UI, then compares that description with the previous one and makes the smallest possible change to the page. Renders are cheap and frequent, DOM updates are neither, and React works hard to keep them minimal. Everything else follows. Type changes throw subtrees away, because a different type is a different thing. Keys exist because position is not identity. And before you optimize a render, you can see in a counter, check whether it is costing anything at all. The kata is the part that matters. Open the lesson, write the code yourself, then read back what you wrote and judge it. The link is in the description, and that practice is what keeps the skill yours.